Oh, we have 9-6, last lesson chapter. Complex numbers. So I get the imaginary unit I. So what happens is if you have the square root of a negative number, the square root of negative c, then you replace it with -1 times c, and the square root of -1 is going to be I, so it's going to be the square root of c I. So when you round this in I form, note the I is outside the radical. It's not inside the radical anymore. So what happens on A is this. So therefore you have, basically it's going to be square root of 36, and then I, that's going to square root of 36 is 6, and then of course -1 is going to be I, so 6I. Hope you all understand that. And I can explain it the way it does here. The negative sign becomes -1, so it's -1 times 36. This goes, if you separate it out, 36 and that, square root of 36 is 6, and square root of -1 is I. So here what happens is going to be 4/5. And since you multiply by -1, the 4/5 will come out there, and then -1 becomes I. And so 4/5 I. If you have -54, you multiply that. Well, 54 is not a perfect square now, so you got to find what's the perfect square inside of 54. And of course, the negative sign just becomes I. So what's the perfect square inside of 54? Well, 9. 9 times 6 is 54, so square root of 9 is 3. So the answer should be 3 square root of 6. Then I's on the outside. And some people just put the I, you can put the I maybe here. In some books, I've seen it done that way. So 3 square root of 6I, or 3I square root of 6. If you have a fraction, well, you can divide these two numbers and get the square root of 16, which is 4, and then if we get 4I. Well, actually, the I's canceled out, sorry. Forgot. Went too fast. Gotta slow down. -1 canceled out, so just simply 4. Now, to perform operations with square roots of negative numbers, you must first write the number in I form. You can add and subtract, multiply as follows. So AI plus BI is the same as A plus B, and then I stays with it. And if you subtract the same thing, if you multiply A times B, and then I times I is I squared, and I squared is always -1. So what happens here is you're going to add these numbers together after you find the square root. So here, let's do it through the PowerPoint. You can read that writing better. So what happens, that becomes -9 times negative, or 9 times -1. 49 times -1, how the book teaches it, but basically it's 3I and 7I. And what happens with 3I and 7I, you add together, you get 10I. This one, if you have one that's not a perfect square, well, you got to figure out what is a perfect square inside of 32, which is 16. So you pull 16 out, then you get square root of 4, you get square root of 4. You get 4 square root of 2, because what happens, this becomes 16 times 2 with the I, so 4 square root of 2I, and that's -2 square root of 2I, and therefore what happens is they both have the same radical, so 4 minus 2 is 2 square root of 2I, and the I is not inside the radical. Now, that takes care of examples 1, examples 2, and let me do example 3 just real fast for you. Instead of adding, subtracting, you could be multiplying two negative numbers. So what happens here is you multiply two negative numbers and you get 15I times 15I. 15 times 15 is going to be the square root. It should be 15 because 15 times 15 is square root 2225. You square it and you get 15. And of course, then I times I is I squared, and we know I squared is the same as -1, so therefore the answer is -15. And you can do this tree property the same way. Now, this complex numbers, this part of it, a number of the form A plus BI, where A and B are real numbers, is called a complex number. The real number A is called the real part, and the complex number is the BI, is the imaginary part. So you have the real part and the imaginary part makes a complex number. So definition of a complex number. If A and B are real numbers, the numbers A plus BI is a complex number, and it's said to be written in standard form. If B equals 0, the number A plus BI is just simply A, if is a real number. If B is not 0, the number A plus BI is called an imaginary number. The number of BI where B is not equal to 0 is called a pure imaginary number. So you have real numbers and imaginary numbers equals complex numbers. So what happens is, let's let this PowerPoint do it. So determine whether the complex number is negative negative. Square root of 9 plus the square root of negative 48 and 3 and negative 4 square root of 3i are equal. Begin by writing the first number in standard form. So we do this. What's the square root of 9? Well, it's the same as saying 3 squared, so it becomes 3. What does it do it this way? So they're breaking it down too for you, but this becomes just simply 3. This one has a negative, so therefore we know the square root that's involved is going to be 16 times 3 with I. So what happens is we find what's the square root of 16? 4, 3, and then I. And so we want to know they're equal. So 3 plus 4 square root of 3i and 4 minus 3 minus 4 square root of 3i are not equal because they're different signs. And then to add or subtract two complex numbers, you add the real part and the imaginary part separately, which is what we're going to be doing in some of the homework. So what happens here is you have 3 minus I plus negative 2 plus 4i. So you group the real part together, 3 plus a negative 2, and you group the imaginary part together, negative I plus 4i. So what happens is you have 3 minus 2, which is 1, negative 1i, that will give you a positive 3i. If you have here, you still group them together. Well, there's only one real part, 5. There's 3i minus 3i. Since they're opposites, they cancel out. Then the answer is just simply 5. If you have more complex, well, let's see here. We have 4 minus, now this is subtracting a negative, so we know we're going to distribute a negative 1. So it becomes plus, plus, and this becomes a minus sign. So 4 plus 1 plus 7. So 4 plus 1 is 5 plus 7 is where we get 12 from. That's the real part. So remember, two negatives make a positive, and then it becomes a negative. So 4 plus 1 plus 7 is that, and the imaginary part will be negative 5 and positive 2. Well, since the signs are different, we know it equals negative 3i. So 12 minus 3i. And if you have one where you have parentheses like this, it's still done the same way, just group them together. 6 plus 2 is 8. Now, 3i and negative minus a square root of negative 8. Well, first of all, you have to pull the perfect square out of here, which is 4 times 2 and I. So 2 square root of 2i. So then you have 3i and you have negative 2 square root of 2i. So what happens is this right here, you have 6 plus 2 is one part. Then you have negative 2 square root of 2, then you have 3i and I. So you have 8 plus 1 minus 2 square root of 2i. So you just group it together that way. Because the 3 minus 2 there is 1. And of course then negative 2 square root of 2 doesn't change, and it's I, and it's all inside parentheses. So make sure you understand that. And then let's see what else we got. Let's see what example I just did. I just did example 5. I might have just done example 6. I did. So example 7 is just multiplying. So I have on example 7. I might have something like, oh, not 17, 7i times negative 3i. So we're going to multiply. Well, 7 times negative 3 is negative 21. I times I is I squared. Well, we all know that I squared is negative 1. So negative 1 times negative 21 is where we get positive 21. Or you might have one like this, where it's parentheses 1 minus I, parentheses, and then you just have square root of negative 9. So what happens is, first of all, we know 1 minus 1i. That's in one parentheses, and then we're going to multiply it. Well, what's this? This equals 3i, because 9 is a perfect square. So now we're going to multiply. 1 times that is 3i. Then you do I times that is negative 3i squared. Well, I squared equals negative 1. You're going to times it by the negative 3. You still have 3i here, so 3i. Negative 1 that is plus 3. And the way you write it is you always write the real number first, so 3 plus the imaginary part 3i. if you have distribute property, do one like this one. Uh-oh, X out. So 3 plus 2i, distribute, or FOIL. You're going to FOIL this out. So therefore you have 3 times 3, which is 9. 3 times this, which is negative 6i. This is positive 6i. And this will be negative 4i squared. Well, this cancels out in the middle, so you have 9 minus 4i squared. Well, I squared becomes negative 1, remember, and this was negative 4. This becomes positive 4, so you have 9 plus 4. The answer is just simply 13. And the last part we're going to do in this lesson is complex conjugates, which is not hard. Most of this is pretty simple. You've done this on number 2. Complex numbers in the form of a plus bi and a minus I are complex conjugates. In general, they have this right here where they kind of cancel. And let's get to the homework. All right, so the example they give you is 4 minus 5a, 4 minus 5i. So your homework is going to say multiply the number by its complex conjugate and simplify. So you're going to do 4 minus 5i. So you're going to write the conjugate 4 plus 5i. So what happens is, it's just like we did a while ago. Actually, the last example was the same thing because they're opposites, which is means we're going to do this FOIL. So 16, since they're opposites, you know it just equals minus 25i squared because the middle term is going to cancel out. Well, that equals negative 5 times a negative 1, which is positive 5. So 5 times my bad, I forgot to multiply. 5 times 5 is 25. Yeah, I did 25. Yeah, 25 there, sorry. So 25 times a negative 1 is positive 25. And then you're going to add it to 16. Because negative 25 and negative 1 makes it positive 25. So 16 plus 25 is where we get the answer of 41. Couldn't read my writing for a second, sorry. And if you have anything like this, it just shows you that, hey, negative 2 equals negative 2 plus 0i. So minus 0i, so therefore negative 2 squared plus 0 is 4. And then you have 3 plus 2i, 3 minus 2i. And basically 3 plus 9 plus 4 is 13. If you have that one. And then we're not going to get to that part. So therefore that concludes 9-6. And then what we'll have also assigned on here is the 3 homeworks will be on here for the Google Classroom. And then we'll have a worksheet. The worksheet is very important that you do. It's going to be a combination of 9-4, 9-5, 9-6. These homeworks, attempt them and then submit them in for just a completion grade. The other worksheet you need to submit and we'll grade it. And then we'll have a quiz also this week on these 3 sections. And then we'll take a test on these 3 sections the following week.